Hi class, so last time we started talking about moles, right? And we said that in chemistry we really care about moles. And 1 mole is 6.02 times 10 to the 23rd. That could be atoms, right? If you have an atom, that could be molecules. If you have a compound, and ions if you have atoms with charges. Now, we said the problem was that you can't physically measure moles because you can't sit there and count 6.02 times 10 to the 23rd, but what we could physically measure is mass. So the last thing I ask you to do, I ask you to write up this chart that mass could go back and forth. You can convert mass between back and forth to moles, and you can convert moles back and forth to atoms, molecules, and ions. And when we went over this chart, and I asked you to have this in front of you as you do in practice problem. And to go from mass to moles or the other way around, what you need is molar mass, or you need molecular weight from the periodic table. And to go from moles to atoms, molecules, and ions, what you end up needing, you need an Avogadro's number, which is 6.02 times 10 to the 23rd. And I had asked you to have this in front of you as you're doing practice problem, and we did a few practice problems to make sure you get the concept down. Now let's keep going with problems and get a little bit harder. You guys can do this. Alright, here's our first problem. How many molecules of carbon dioxide are in 5.00 moles of CO2? All of these problems I'm going to put up. Pause me, do the problem, and then check the answer, and then unpause me and check the answer. Okay. Alright, let's do this. So, you're going to write down what's given to you. What's given to you is 5.00 moles of carbon dioxide. Now, what you want, you don't want moles, you want molecules. You have moles, you want molecules. I'm going to come over here. I have moles, I want molecules. I'm going to go from here to here. How do I go from here to here? I use Avogadro's number. Then I'm going to come back here. I said I don't want moles. So moles is going to go down here. What do I want? What I want is molecules. What I want is molecules. So far so good. So in this case, the moles can cancel out and I can end up with molecules. Now, how do I go from moles to molecules? Avogadro's number. How do you go from moles to molecules? Avogadro's number. And we said Avogadro's number is always for 1 mole. Is always for 1 mole. 1 mole is 6.02 times 10 to the 23rd. Avogadro's number is always for 1 mole, right? 1 mole is that number. So far so good. So the moles cancel out, and what I end up getting is molecules. Now, make sure you have your calculator out and make sure you get this right. So it will be 5.00 times this number. If you do it, now before we do this, how many sig fig should our final answer have? How many sig fig should our final answer have? So let's go over this. This is how many sig fig? This is 3 sig fig. Beautiful. This one doesn't count, exact number, it's a conversion, you didn't measure it, so our final answer should have 3 sig fig. So if I do this, what I end up getting for the final answer is 3.01 times 10 to the 24 molecules of carbon dioxide. So far so good? Okay, you ready to go for the next one? Beautiful, let's do the next one. Next problem, okay. I ask you, what is the molecular weight of silver nitrate? Okay, what is the molecular weight of silver nitrate? Now, we've talked about this before. How would you figure out the molecular weight? To figure out the molecular weight, you would add up the molar masses of all of these compounds, right? So I have silver. I would find silver. Where is my silver? Okay. Silver is right here, so that's 1 silver. So I have 1 silver. Then nitrogen, here is nitrogen. I have 1 nitrogen, and then oxygen. How many oxygen I have? I have 3 oxygen. So it will be 3 times that number plus 1 nitrogen plus silver. So So you have to add up all of these, 1 silver, 1 nitrogen, and then 3 oxygen. And you have to add them up together. If you do that, what the answer that you get in this problem, you get 169.87 grams per mole. Okay, that's the answer we're gonna get. So that's how you would do molecular weight. You would add up all of them together, and then add up all the atoms together, and then write down the molecular weight. So far, so good. Okay, ready for the next one? How many moles are present in 26 grams of N2? Okay, now let's do this one. I'm going to write down what's given to you. You should always do that. You go, okay, the grams of N2 is given to me. So I'm going to write down 26 grams of N2. You following me so far? Okay. Now, what we have gram. What we want is moles. I'm going to go back to this again. What we have is mass. We want moles. Can we go mass to moles? Yes, we can. What do we need? Molecular weight. Okay, so I'm going to come back here. So I don't want grams. I don't want grams. Where does it go? It goes down here. Now what I want is mole. Okay, so in this case, the grams can cancel out and I can end up with moles. Now, how do I go from gram to moles? Molecular weight. Gram to moles is molecular weight. You following me so far? Okay. Now, what is the molecular weight of N2? N2's molar mass of nitrogen is 14. You have 2 of them. 14 plus 14 is 28. That would be the molecular weight of N2 would be 28. You following me so far? Okay. Now, so the molecular weight is 28, and we said molecular weight is always for what? Molecular weight is always for 1 mole. That's really key. Molecular weight is always for 1 mole. Okay. So, if I do this, what I end up getting, I'm going to have 26 grams divided by 28. What I get is 0.93 moles of N2. You guys follow me so far? Okay. Not bad. Not bad. Now, again, you have grams. You're going to go gram to moles. You know you need molecular weight. The grams cancel out. I have moles on top. I figure the molecular weight of N2 is 28. Molecular weight is always for 1 mole. Grams cancel out, mole. I'm good. One last thing is that when you look at the periodic table, for example here, when I look at the periodic table, when I look at the nitrogen, it's 14.0067, right? Now, do I take all these numbers or do I not take all these numbers? That would depend on this one right here. This is my sig fig. This one right here is 2 sig fig. This is my sig fig. This is my sig fig in this problem. So in this entire problem, I am limited with 2 sig fig. So your molecular weight should match that sig fig. Because molecular weight is not something you measure. You can just take it from the periodic table, right? It's almost like an exact number. You can just take it from the periodic table. You didn't measure that. So again, this sig fig has to match this one right here. So far, so good? Okay. Beautiful. Ready for next one? Here is our next problem. We have 48 grams of Cl2. We want to know how many molecules of Cl2 we have. All right, now we just took it to the next level. Now, before I do this, I'm going to write this down. I'm going to write down to remind myself that I can go grams to moles using molecular weight. And I can go moles to atoms, molecules, or ions using Avogadro's number. Okay? Alright, so in this problem, what's given to me is 42.0 grams of Cl2. Write down what's given to you. What's given to me is grams. I am right here. What I want is molecules. This is what I said. We're going to the next level. I have grams, but what I want is molecules. Can I jump? Can I just jump from grams all the way to molecules? You cannot. That's too much of the jump. So what I need to do, I need to go from grams to moles and then moles to molecules. You guys follow that? Okay. I have to go from grams to moles and then go from moles to molecules. So you can't just jump. You have to go from grams to moles and then go from moles to molecules. Okay, we can do that. So I'm going to come over here. First, I have to go from gram to moles, right? Gram goes down here, so it could cancel out. What I go on top, I'm going to put the moles. How do I go from gram to moles? Molecular weight. Molecular weight. Okay. What is the molecular weight of Cl2? Molecular weight of Cl2 is 70.9. 70.9 gram. And you can remember, molecular weight is always for 1 mole. Molecular weight is always for 1 mole. Okay, so that's great. So what I've done so far, I've gone from gram to moles. Now I have to go from moles to molecules, right? I have to go from moles to molecules. I don't want moles. It's going to go down here. What I want on top, I want molecules. Okay? So I don't want moles. So moles goes here. So the mole can cancel out, right? And what I want is molecules. Now, how do I go from moles to molecules? I use Avogadro's number. And I know I repeat myself so many times, but do listen. Avogadro's number is always for 1 mole. So 1 mole is 6.02 times 10 to the 23rd. 1 mole is 6.02 times 10 to the 23rd. So the moles cancel out, and this is what I end up with. You guys following me so far? Okay. Now, just really quickly, to make sure that you guys get it right, how did this number come from? Because I have 2 Cl. So molecular weight of Cl times 2. And then this matches up with the sig fig of this one. How many sig fig is my problem? My entire problem is limited to 3 sig fig. Because this is what I have. This is what I measure, 3 sig fig. So my final answer should have 3 sig fig. Now, I'm going to go step by step, making sure you've got this down. So, you're going to go 42.0 times 1 times 6.02 times 10 to the 23rd divided by 70.9 and then divided by 1. You don't need to write 1. And if you do that with 3 sig fig, what I get is 3.56 times 10 to the 23rd molecules of Cl2. And that's 3 sig fig. Yeah? Okay. Hopefully you guys are getting the hang of it. And remember, this is always for 1 mole. This is always for 1 mole. Next problem. Okay. How many molecules are in 145 grams of glucose? Glucose. What is that? That's sugar, right? That's sugar. This is a formula for sugar, C6H12O2. It's kind of cool, you know, the formula for sugar. So next time, when you're adding sugar to your tea or coffee, what are you going to be thinking about? You're going to go, oh, I know the formula of this. It's C6H12O6. I'm completely ruining life for you, huh? Chemistry is everywhere. I want you to be thinking about those. So what I got here, I have 145 grams of glucose. I'm not even going to read the question. I'm just going to write down what's given to me, which is 145 grams of glucose, which is C6H12O6. Think about that when the next time you use it, sugar. Now, here's the glucose, okay? Now, I want molecules and I have grams. We know how to do that. So I have grams. I want to go to molecules. Can I jump? I cannot jump. I have to go gram to moles and then moles to molecules. Beautiful. You know how to do that. Then I'm going to come over here. Do I want grams? Nope, I do not want grams. So it's going to go down here. I want moles. It's going to go on top. So then the grams can cancel out and the mole can go on top. How do I go? How do I go from gram to moles? Molecular weight. We say molecular weight is always for 1 mole. So you would have to calculate the molecular weight of that. If you calculate that, what you end up getting is 180 grams. So far, so good. Okay. Now, I don't want moles, do I? No, I do not want moles. So moles is going to go down here. And what I want on top, I'm going to put molecule. You guys are still following me? Okay, because I don't want moles. Moles can cancel out. And what I end up with molecules. Remember, canceling out is your best friend. So how do I go from moles to molecules? Avogadro's number. Again, we were in grams. We went gram to moles, molecular weight. Now moles to molecules using Avogadro's number. There was gram down here. They can cancel out. 1 mole was 180 grams. That's the molecular weight of this. Now I don't want moles. It's going to go down here. What I want is molecules. Now the conversion. 1 mole is 6.02 times 10 to the 23rd. Avogadro's number is always for 1 mole. So 1 mole is 6.02 times 10 to the 23rd. Okay, so the moles cancel out. I end up with molecules. Now, how many sig fig is my entire problem? I have 3 sig fig, so I need to be bounded by 3 sig fig. If I do that, my final answer is 4.85 times 10 to the 23rd molecules of glucose. Yeah? Okay. Now really quickly, so this is 3 sig fig. Now if you look over here, after I added the molecular weight, all the molar masses, I have 6 carbon plus 12 hydrogen plus 6 oxygen. I get 180. And what I did, I put a little 0 over there. So 180 is 2 sig fig. You agree? 180.0 would be what? How many sig fig? 4 sig fig. You guys know that. Now, if I just say 180 and put a period, put a dot, but don't put a 0 here, that is considered 3 sig fig. So basically, if I measure it accurately to 180, but not accurate enough to 180.0, this is the way to get around it. This would be 2 sig fig, this is 4 sig fig, but if I just put a dot, put a period, but don't put any 0, that would be considered 3 sig fig. So this is kind of like a side note for you guys to learn. Beautiful, you guys are doing so well. All right, here's a take-home problem. Yes, of course you're gonna get a take-home problem. You're gonna get a take-home problem to do. Now, what I want you guys to do, how many grams contain 6.60 times 10 to the 21st molecules of gold-3 nitrate? Now, here's my hint to you. Write down what's given to you. Look at the chart where you're trying to go and cancel out, because canceling out is your best friend, right? We've talked about that. Canceling out is your best friend. And then what you need to make sure you know is the formula for gold-3 nitrate. I'm trying to test you to make sure you remember your naming, right? All right, this is your take-home problem. Now, before I let you go, I have a little fun surprise for you. You guys have gone to Trader Joe's before, right? Next time you are at Trader Joe's shopping, grocery shopping, I want you to go to the guacamole section. There is a guacamole that they sell that has a chemistry joke on it, which is very interesting because I feel like most people have no idea that this is going to be a chemistry joke, but it's there. And you will know. You're one of the few people who's going to say, oh, this is funny. Let me bring it up. I have a picture of the product. Okay, so next time you're at Trader Joe's, you are going to go and find this product. And you're going to read the chemistry joke and you're going to be laughing and everyone's going to be thinking, why are you laughing? That's what it means to be a science nerd, right? So check this out. Avogadro's number, guacamole. Now take a guess. Who is this guy? This is Avogadro, like the guy who came up with Avogadro's number. Isn't that cool? And this sounds a little mean, but it's so true. Doesn't Avogadro kind of looks like avocado? No, like a long face, just a little bit. So this is Avogadro who came up with Avogadro's number. I still think he looks like avocado. Now it says avocado's number guacamole. Now this is the joke on the back. We could think of no better name for our new guacamole than avocado's number. The number of premium has avocados mixed into this guacamole. Anyway, so it goes down to this one. There aren't 6.02 times 10 to the 23rd avocados in here, but 5 plus avocados isn't bad. Isn't it so cool? Because it's guacamole, so it's mole. So you would think there's 6.02 times 10 to the 23rd, but no, it's only 5 avocados. Okay, I'm getting a little too excited here. Hopefully you guys are also getting excited. Yeah, that's kind of cool, right? That they have a little hidden chemistry joke on their product. So next time you are at Trader Joe's, go check it out. And you can even explain to the people around you that what this means. I tried that before. They looked at me weird, so maybe don't do that. But you know what guacamole is. You know what mole is. You know avogadros. So it'll be fun little surprise when you go to Trader Joe's. They have a couple of things like this, so we'll show you more stuff that you can find. All right, I will talk to you guys next time, but don't forget, do this take-home problem. Okay, I will see you next time.